Hi, this is Kristen Hess. I'm going to use 3-column notes to talk about our math concept for today. We're going to talk about finding the area between two z-scores. Our question is specifically looking to find the area between z equals negative 1.5 and z equals 1. Before we get going, I want to make sure you understand what the normal z distribution is. So it's a bell curve shape. It has a mean of 0 and a standard deviation of 1. So here's a quick picture of it. Let's talk about it a little more. Notice how it's a symmetrical bell curve. The area under the curve is 100%. It can go on beyond -3 and +3, but most of the area is right between this -2 and +2. The mean is always 0, and each of these steps out is kind of like a number line, -3 up to +3. Represent z-scores and also, in this case, standard deviations. So we're going to be using a normal probability app. Feel free to follow along. So this app I find very helpful to visualize what's going on. Notice that the blue represents the area up here, and down below you can type in the z-score you want. So if I want to use a z-score of 2, I can shade what I want. So if I want to know the area between a z-score of -2 and +2, right here, we're going to get 0.9545, or about 95% of the bell curve is between -2 and +2. I can move it in and find that the area between -1.014 and +1.014 is 0.07021, or about 70%. I can shade a little bit higher and know the area from -1.041 and above, or I could find below, or just above. But notice how there's that symmetry going on here, and the area is always this shaded area, and the z-scores tell us how far we stepped away from the mean. So going back to our original problem, we want to know about the area between -1.5 and +1. So I'm going to use the normal probability app to start looking at the area between -1.5 and 1.5. And so I'm going to take this and move it over here to another screen so I can work on it. And I'm going to do the same with the area between -1 and +1. Notice that these two values have to be the opposite of each other. I can't put in different numbers in the different boxes. And so there's a little bit of work involved. But I'm going to take this diagram, I'm going to change colors on my work screen so that I can tell the difference between the two. So the area between -1.5 and positive and negative is about 86%. The area between -1 and +1 is about 68%. So down here, I've put the two images together. So notice that with the bigger z-score, the blue diagram with the -1.5 is a little bigger than this one. And so something I want you to think about is that symmetry. So if I draw a line straight down the middle, I'm wondering, what is this blue area right here? Because this diagram over here, my answer, what I'm looking for, is the area between -1.5 and 1. So I don't need this right here. But because of the symmetry, these two areas right here, we can find them. If we can find what these two are together, we can divide it by 2 and subtract it off. And so what I'm going to do is I'm going to take the area, the larger area, and subtract off the smaller area. So the larger area is 0.8664, or 86%, and I'm going to subtract off the smaller area, which is 68%, 0.6827. And that will tell me the difference, how much bigger the larger one is from the smaller one. So 0.8664 minus 6827 0.27 is going to give us 0.1843. So 0.1843 tells us the blue area in this area down here. And so I'm going to write that right here. So 0.1843 is that area and that area combined. Now because of the perfect symmetry, I'm going to divide it by 2. And that will tell us how much is in each piece. So we'll take the 18.1843 and divide it by 2. And that gives us how much is in each piece individually. And so in each piece individually, we have 0.09215. So now to find what we're looking for, we're going to take this whole area, the whole blue area, and subtract off just one of these pieces. So to find our purple area that we're going to look for, we're going to take that 86% that we had originally, 0.8664, and subtract off the 9%. And when we do that math, 0.8664 minus 0.09215, that will tell us that the answer that we're looking for, the purple area, is about 77%. And that's how we are going to use this. So in summary, let's wrap this up. So in summary, we talked about what is a standard normal curve, bell curve with symmetry, standard deviation of 1, and a mean of 0. We talked about using the probability app and how you're going to use it to find the area between two z-scores and how you're going to have a few different steps to get there, but you can use that symmetry and some algebra to always find the area between any two z-scores. Thank you.